Number 27, what is the freezing point of this solution? Shh. 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 All right, so freezing point, shh. Freezing point and boiling point increase, freezing point depression, boiling point increase, starts out with this calculation. We have a change in temperature. That's the change from the original freezing point to a new freezing point. Okay, so that's not the end of the calculation. That's where you start. Okay, is equal to I, that's the Van Hoff factor. That's the number of particles the solvent breaks up into in solution. I times K times M, which is molality. Okay? Now, since this is freezing point, this is change in temperature freezing and a K sub F. Okay? All right, we're going to look at this. We're looking at this solution here, aluminum sulfate. Aluminum sulfate. Aluminum sulfate. And aluminum has what kind of charge on it? 3 plus. And what about sulfate? 2 negative. So we got to have 2 of these and 3 of these. Okay? Which means that, therefore, I equals 5. Okay? I equals 5. All right, so we know what that is. All right, let's see. So I is 5. And then we're going to multiply that times the freezing point constant. And for water, because when you're looking at the freezing point constant, you're looking for the solvent itself, the solvent here. Okay? And so it's 1.86 degrees C divided by molal. Yep. Negative 1.86 degrees C divided by molal. All right? Now we got to figure out what the molarity is. We've got some more calculations to do for that. Let's move down a little bit on the paper here to do that. So we're starting out with this solution where we've got a 1.00 grams of, no, I'm sorry, 10.00 grams of 10.00 grams of aluminum sulfate. Okay, and we've got 100 grams, 1.0 grams of water. So, do you want me to do this as one calculation the way I did a while ago, or do you want me to do it as 3 separate calculations? Are you sure? Aaron, are you sure?
I don't want to get confused, man.
Pretty sure.
Because we did one and we did the other one.
One makes it easier.
I think it does, but if it confuses you, I can do it as 3 calculations. All right, we'll do it as 1. So I'm going to start. I know when I want molarity, I want to get moles of solute over kilograms of solvent. Okay? So I'm going to go ahead and put whatever measurement I have for my solute over whatever measurement I have for my solvent. I've got 100.0 grams of H2O. Okay? What I need to do is be able to convert this one into moles and this one into kilograms.
Bless you.
All right? To get grams to moles, I need molar mass. Aluminum, sulfur, oxygen. The molar mass of aluminum, 26.981,538. Sulfur, 32.065. And oxygen is 15.9994. So we're multiplying aluminum by 2, sulfur by how many times we're going to multiply sulfur? 3. And how many times we're going to multiply oxygen? 12. Okay. Well, we are going to get a big honking number, I guess. You need to get your cal out. Okay. All right, so 26.981,538. And I get, times 2.
I got 53.963076.
Okay.
71.9928.
Well, I'm trusting you. Since I'm recording this on video, I want people to be able to see what we're doing.
Okay. Plus 96.963. Whoa, that's a big honking number.
Like, yo, what? 342 was 5.
Equals, and then you have to round it off.
That's a 7.
Okay, we're going to round off 3 digits.
Round off as you go. But that one works too. It helps me remember.
Yeah.
Mole of Al2.
Okay. So now this equality statement allows me to build the conversion unit I need to convert grams to moles. I'm going to put grams down here on the bottom
Moles on top.
because I got grams here on the top. I want grams on the bottom. 342.151 grams of aluminum sulfate. And I'm going to put 1 mole of aluminum sulfate on the top. And I can cancel grams and aluminum sulfate. And I can see that I've successfully converted to moles on the top. Now I need to convert grams on the bottom to kilograms in order to get to molality. Well, we should know, I hope you know now, that there are 1,000 grams in 1 kilogram. There's the equality statement we need to build the conversion unit we need. To convert grams to kilograms, we need this grams on the bottom, so the grams from this side of the equality statement need to be on the top here. And the kilograms go on the bottom, that's where I need them in the end anyway. Grams are going to cancel, so now we have moles of the solute over kilograms of the solvent, and what we're ready to do is to actually do the math solution. Okay? Alright, so we're going to have 10 here, times 1,000. Hit enter. Alright. And then we're going to divide by the 100 here. Hit enter. Then divide by 342.151. And hit enter. Okay. And I got 0.292268. 6182. Okay. Moles of aluminum sulfate over kilograms H2O. Now this, moles of this over this, is mole. So when I do my rounding off, I can change actually that unit to that. Let's see, how many units do I need to round off to? I need 4 units of my answer. Okay, so we're going to round it off then to 0.2923, and since moles of aluminum sulfate over kilograms of water is molal aluminum sulfate, okay, I don't have to say it's in water because that's assumed, okay, unless I say otherwise, and that's our molarity. Now we're ready to plug this number up here. Alright, so we got 0.2923 mole. We don't even need the species up here. Okay? But by setting it up this way, and I'm going to go ahead and put this over 1 to show how everything works out. Molal cancels. We're left with degree C. What is degree C? What does the unit of measurement? Yes. The unit of measurement, degree C, measures a temperature. Okay? So that's going to give us our temperature change. All right, let's do our math
There you
here.
go.
5 times a negative 1.86 and times 0.2923. Oop, I left the 9 out. Okay. I hit enter. And I get a change in temperature of negative 2.71839.
6, 4,
And then the units we have left, degrees C. We need to round it off to how many digits? 3 digits. Negative 2.72 degrees C. Okay? For those of you watching on the video, just a reminder of something I said a long time ago, we round off in every step even though it propagates an error just so we can practice it over and over again.
For sure.
It's actually better to wait till the very end to do all the rounding off, but that gets really complex. All right. The change in temperature. The change in temperature of freezing is the original temperature of freezing for pure water plus, that's not right, change in temperature, it's final minus initial. So it's the temperature final of the solution over the temperature initial of just the solvent itself. Okay? That's the point. The point, but
We have to write that down to get a point.
no, you know that the change in temperature is negative 2.72 degrees C. The temperature final is what we're trying to find. The temperature initial is 0.00 degrees C. And we want to find this, right? No, that is wrong. You're right. It's minus. This is minus, which...
So then you put the Celsius over there and you subtract something.
Boom.
So it actually ends up as your temperature of freezing for the solution is negative 2.72 degrees C because we're starting at 0 and going down. Okay?